the cutting angle between a straight line and a plane, how to calculate that. So you first need some sort of intersection, and this is how you can make an intersection. And so here we have the plane and we have our straight line. You see maybe there's some sort of angle, of course. Then we have an intersection point and we have a cutting angle. So this is the angle we can calculate with the following procedure. And it looks funny and it's not that difficult. You just need to know by heart one formula. Then you put in your information given in the exercise and you end up with a cutting angle. So not too complicated, and I will show you how it works. How to calculate the cutting angle between a plane and a straight line. This is actually quite easy when you know the formula to calculate it. And I'm going to show you how to do that with an example. So our plane is the following. I call it E, which is 1x1 plus 4x2 minus 6x3 equals minus 4. And note that this is the coordinate representation of a plane. So we can say the normal vector is this one. Actually, the plus would belong also to the 4. And then we can say we call it n. This is our normal vector, and we already know it because, as I just said, 1, 4, minus 6. We can see it actually in the representation of the plane, in the coordinate representation. And what else do we need? Plane, we need, of course, the straight line. So I call it G equals 2, 9, 3 plus R times minus 5, minus 6, minus 4. And note that R is some sort of number. It is not a vector. And what else do we need? We say this, the direction vector of G, we call U. So I can write it again. U, directional vector, minus 5, minus 6, minus 4. So actually now we already have everything that we need to input in the formula. But what is the formula actually? Formula is the following. We say sine of alpha is the product of n and u. And then we take the amount divided by amount of n times the amount of u. So if you know this formula and you have given this plane and this straight line, then it's very, very easy. You just have to insert the vectors. For calculating the angle, you need some sort of calculator, and then you have it. So it's not too complicated, but you can make mistakes, of course, but with a little bit of practice, it's very easy, and you have to know by heart the formula, of course. So we say n times u. As I said, we take the vectors from above, so we have 1, 4, minus 6 times minus 5, minus 6, minus 4. Then we take the amount divided by the amount of n, which is 1 squared plus 4 squared plus 6 squared, square root, times. And note that I wrote 6 squared because the minus disappears. When I say minus 6 squared, it's the same as 6 squared, right? So to make life easy, I always write plus, since it's easier than later to put into the calculator. And the same with the second vector, I say 5 squared plus 6 squared plus 4 squared. So it looks a little bit long, so now we just calculate the product here, which is minus 5 minus 24 plus 24. Then we take the amount, and maybe we can already calculate the product here, which is then square root of 1 squared plus 4 squared plus 6 squared times square root of 5 squared plus 6 squared plus 4, also squared, which is this. Doesn't look too nice, but this is it. 63.9, and we save this in A. So store in A to make life a little bit easier. And then we can calculate further. Then we know, okay, this cancels out. So we have 5 in the end divided by 63.9, which we know is saved in A. Then we can easily calculate it. So we say 5 divided by, okay, in this case I don't need A, I can also take answer, and I have this value then. So the value is 0.078 something, but now I'm going to save it to B. Store to B. At B, did it work? Yes, store to B. And now we have sine of alpha. We know this is this value. And to calculate alpha now, what we're going to do is, I make one step more to show you. So we have sine alpha equals 0.078. What we are going to do is, we take the inverse sine. Then we end up with alpha is the inverse sine of 0.078. And how to calculate that with the calculator? Works the following. We press Shift, sine, and then our value, which we said we had saved in B. Then we end up with something. But then actually there's always someone or several students in a class who have this problem, and actually maybe you can't see it, but here there's an R. So there's a problem when we want to calculate angles in geometric angles, because the R says us we are in radian mode. So this value is radian value, but we don't want that. We want a geometric angle, and how to obtain that, I'm just going to show you. Press mode, and somewhere you end up with degree dec. Then we change, and then we are in degree, and then we do the same calculation again. We say Shift, sine, B, and then we end up with a nice geometric angle, and this is what is required in this exercise. Maybe your teacher or your professor wants you to give the solution in radian, but you have to ask, you have to know which mode you need, degree or radian. It makes a difference. So in this case we can write degree, so we have 4.49 degree. And this is our cutting angle between the plane and the straight line. So actually all the calculation is not too difficult. You have to know one thing. You have to know this formula, which is important, because finding out the formula in the exam may take too much time, so it's a lot better just to know the formula. And those two vectors, and at U you can obtain one from the plane, the other one from the straight line. Then you just put in the vectors, you calculate it, and you end up with your cutting angle. So it's not too difficult, but of course practice makes perfect. Thanks for watching. Practice makes perfect. Further exercises with solutions you can find on my website, which is www.worksheets.com.